Hi everyone. In the last session, we discussed about the Towers of Hanoi problem. So, as we have defined, we have given three pegs, only A, B, C. You can make use of A, B, C, and you can move the disks from one peg to another peg. But the final objective is to move the disks from source peg A to C. So, in the middle, you can use the help of auxiliary peg that is called the B. Right? And we have seen there are four important conditions. Only the top of the disk is moved. At a time, only one disk can be moved from one peg to another peg. And another thing is larger disk should not be placed on the smaller one. And finally, you have to move all the disks from source peg to the destination peg. And we have implemented the code. Just we have defined the function of towers by using the tree representation. If you are understood about the tree representation, then the programming code is very easy. See, when by seeing the programming code, if you trace the execution or the statements one by one, it is very difficult to understand the program logic. Why? Because so internally a stack is created and all the function calls are pushed onto the stack and they are popped one by one. If you are able to understand only the tree representation, then it is very easy to understand the program, right? So now in today's program, in the today's session, we are going to implement the program for the Towers of Hanoi. Let us go to the Towers of Hanoi program, right? So here I'm writing program for Tower of Hanoi. Don't say Towers of Hanoi, just you say Tower of Hanoi, right? The first statement hash include stdio.h int main opening brace. Now here, don't verify the program. How to write the program? That is very, very important. So the length of the code is very less, but internally the execution part is totally different, right? Now, in the main, we are going to call the towers function, right? So what are the arguments that we are going to pass the towers? The number of disks as well as the peg names, or we can say pole names. So for that, what you do is number of disks declared as a variable integer n, right? After this, do take the go for the towers of Hanoi function declaration. So the return type for this is void. I'm writing tower or towers. You can write tower. I'm taking only tower. I think previously we have taken towers. Okay, you can write towers. Void towers. For this, the arguments we are going to pass is one is integer, another one is character, next character, again character. Right? This is the function declaration or function prototype. The name of the function is towers, right? The return type is here void, and after that, first argument is of type integer. Integer in the sense number of disks. So here the name of the integer is not mandatory, it is optional. So that's why I'm not giving the name. At the time of calling, I will give the name, right? So next second type is character. Character means the source pole, A, capital A or anything. So I'm using capital A. Now second one is again character, that means B, and third one is character. Again, we are referring to C. This is function declaration. After this, what I'm going to do is I'm going to say printf enter, just you say enter number of disks. Number of disks. That means we are going to read n value. You can give any value for n. You read scanf percentage d double quotes close comma ampersand n. So n we are reading. N may be 3, 1, 2, 4, anything, right? But the poles are only three A, B, C. So after reading n number of disks, so what I'm going to do is I'm going to call the function towers. I'm going to call the function towers. Right here, I'm going to pass the arguments, actual parameters we see. First, n indicates the number of disks. Next, in single quotes, I'm mentioning A. Why? This is a source peg. Character constants are enclosed in single quotes, comma. Next, B, comma. Next, I'm going to take C, capital C, A, B, C. After this, semicolon, and finally you say return 0. This is the block of the main. Now, after the main, now we are going to define the function void towers that we have already seen in the yesterday's class, void towers. Now, here, what I'm going to take the variables are, so here I'm going to mention the formal parameters. In the formal parameters, what I'm going to use is the data type, integer, n, I'm taking the variable n, next character. So capital A is nothing but the beginning peg. Just for that, I'm using BEG. BEG means beginning peg, comma, and B is nothing but auxiliary peg that we call it as AUX, auxiliary peg. The variable name may be either single character or more than one character. Next, last one for C, we are writing as end peg. C is the destination peg, or we call it as end peg. So this is the different terminology I'm using. Now, after this, how to implement the code. Yesterday, we have seen only the function definition, only the code of the function. There I said that the first condition I'm saying if. You say if n equals to 1, what you have to do? If n equals to 1, directly you can move the disk from source peg to destination peg, or we can say beginning peg to end peg. So for that, if n equals to 1, what you do is printf, you write in double quotes, you write printf, percentage d is moved from percentage c to percentage c, right, slash n, double quotes close, comma. First percentage d is nothing but the disk number. So generally, the topmost disk is numbered 1. Next, the second 2, 3, 4, right? The bottom one is given as the largest number. So percentage d is moved from percentage c to percentage c. First percentage d is nothing but the value of n, comma, percentage c to percentage c means source peg to destination peg, or we can say beginning peg to end peg, right? This we are writing here. Now, if number of disks are not 1, if it is only 1, directly you can move from A to C. A to C means beginning to end. Else, what you do is, then you go for the recursion. Now, under else part, as we discussed yesterday, there are three important statements, right? So, the first statement is we are calling again towers. So, at the time of drawing the tree representation, I said we are starting from towers, first to towers, means from the main we are calling the function towers. So that we have said that that is a root node. From the root we are moving to the left, again left until we get the number of disks is 1. When the number of disks is 1, we are moving up to the parent that is called root. The root we are executing the second statement printf. Yesterday I said after executing the printf statement, then we are moving to the right. The right in the sense last towers. So here what I'm going to do is, first I'm going to type towers, left function towers. Here what I said is just you write n minus 1. Now how to write that in the first towers function? See, first towers, what we are going to do is, in the first tower function, so if you want to move the disk from A to C, first what I'm going to do is, first you take only first two pegs. What are those? A and B. So when you take only first two, what happened is the source is A, the destination is B, right? So source is A and the destination is B. Now, when the source is A and the destination is B, that is specified loss. What is the left to middle one? The left to middle one is becomes C. That is the logic I am going to use. So n minus 1 number of disks. Okay. Now the source peg is what I said beginning, right? Now you give comma, you give some space here, comma. Beginning is the, so first I'm writing the source peg and finally I'm writing the end peg or destination peg. When you consider only two pegs A, B, A becomes beginning and B becomes end. So end we are taking. So in the middle, what we are going to get is, we are going to get auxiliary. Okay. So the default is filled with auxiliary. Why? Because beginning is, sorry, beginning is the when you consider beginning and auxiliary, sorry, here. When we consider AB, that means beginning and auxiliary. AB, beginning and auxiliary. Then A becomes source and auxiliary becomes destination, and the middle one you write the remaining. What is that? End. This is the logic you have to use for implementing the first towers function, right? Now, after printing the first two towers, the second statement, that is print statement. Now printf, here you write percentage %d is moved from percentage %c to percentage %c, right? Slash n, if you want to write, you can write slash n, comma, comma. Here what you do is, after closing double quotes close, comma, here you write first n value, comma. Now source peg is nothing but beginning, right? Right, end peg. What is end? Just you write source beginning and you write last, you write end, beginning and end. Now you write another towers. So last towers, what you write? You consider last two pegs. Last two pegs are, first one is last two. When you consider last two are auxiliary and end. Auxiliary becomes the source, end becomes the destination. Now here I am writing n minus 1. You write auxiliary, comma, you give space, last you write end. Now here the remaining empty space is occupied by, what do you do? This is called beginning, right? So here you have to write in this way. And finally you put semicolon. So this is the way of writing or implementing the code. Okay, now okay, else part is completed. Else part is completed. Now at the time of discussing, I said that if n equals to 1, so we are moving on from root to left to left to left to left until we get number of disks is 1. If the number of disks are 1, then the first printf statement, this printf statement is executed. Else what happened? Left to towers, again towers, left to towers, left to towers, left to towers. This is repeated until we get 1. When we get 1, this is executed. After executing this, what happened? We are moving back. This printf statement is executed. You can have one doubt. When the condition is false, why you are going for the else part? This is not the correct explanation. Even though the condition becomes false, it is going to enter into the else part and it is going to execute the printf statement. Why? Because it uses the concept of the stack. So that's why I said the tree representation is very, very important. Now, first we will save this program and we will check whether there are any errors or not. Control S. Now you run it. You see, it is asking enter number of disks. So we have seen yesterday the number of disks are 3, right? Then we got the output like this. You see here. Whenever I give 3, here we are writing that 1 is moved from A to C, right? 2 is moved from A to B, 1 is moved from C to B, 3 is moved from A to C, right? Now 1 is moved from B to A, 1 is moved from B to A, and 2 is moved from B to C, and 1 is moved from A to C. You see this. This is the logic. We are moving disk 1 from A to C, next disk 2 from A to B, right? 1 is from B to C to B, right? Next 3 is from A to C. Now 1 is from B to A, and 2 is from B to C, and 1 is from A to C. You can solve this problem by using pen and pencil on your own. This is the logic. Now, how it is going to print? Already we have seen the tree representation. So if you want to give more number of disks, you can give more number of disks. We will try for that. So here it is asking again enter number of disks. Here I am writing 4. You see here. For 4 also we got the output. How many steps? 1, 2, 3, 4, 5, 6. There are so many steps. You can give any number of disks, right? Again, I'm executing. So if you give 3, it is printing our tree structure yesterday we have seen. 1 is moved from A to C. So let us go for the execution part very fastly. Okay, execution starts from the main. Okay, right. Just I'm going to explain fastly. Already we discussed yesterday. So we are taking number of disks here and we are calling towers, right? When we call towers with n value 3, then from here we are moving to this. So first to root node. What is the root node? We have explained in the tree structure, towers. Here we have given n value 3, right? Here beginning we said A. You observe the tree structure. Auxiliary is B. Now end is nothing but C. There I have written 3A, B, C. But on A, B, C I have written beginning B, auxiliary A, and I denoted E. Now come here, n value how much? 3. N equals to 1? No. The condition is false. When the condition is false, which part is executed? Else part. Here we are calling towers. Means from the towers 3 A, B, C, we are moving to this towers. From here again directly moving to this. Okay. So here beginning becomes, see here, n minus 1 becomes n. This beginning becomes beginning. This end becomes auxiliary. Understand this, please. This auxiliary becomes end. Name of the parameters are changed here. Now come here. N equals to 1? No, n equals 2, right? So again, this printf statement is not executed. Again, we are moving to this towers. In this case, n value becomes 1. Now again, we are calling towers. Okay. Now in this case, n value becomes 1. When n equals to 1, what happened? It is printing percentage d is moved from percentage c to percentage c. So first percentage is the value of n, that is 1. 1 is moved from percentage c is the value of beginning. Beginning is how much? A. 2 is printed as it is. Percentage c means end. End means c. So 1 is moved from A to C. That is a printf statement is going to give. So after executing this printf, so you think that this else part is not executed. But after executing this printf, what happened? This towers function is terminated, right? The towers function with 1, okay, with 1 and some arguments A, B, C, that function is terminated and it is popped from the stack or it is deleted from the stack. So after it is deleting, automatically the cursor, the control is moved to the next function call in the stack. So what is the next function call after deleting the towers 1 ABC? What is the parent of that? That is towers 2 ABC. So it moves to that part and it is going to print this statement. After printing this printf statement, now directly it is going to the last towers. That means we are moving right. This is repeated so many times, and whatever we have drawn in the tree representation is the exact explanation of this program. If you are able to understand the yesterday's tree representation, this is the logic. Okay. So with this, we have completed the program for implementing Towers of Hanoi. Next, we will see the introduction of storage classes. Now we will see the storage classes in C. We will discuss the storage classes. What is mean by a storage class? First, storage class. What does it mean? See here, generally we declare the variables like this, right? Integer A. When we say integer A, this int refers to the data type and this A refers to the name of the variable. Name of the variable. Okay. Now, the important thing is integer A, so we call it as declaration. We call it as declaration. Declaration. See, another word we're also using definition. Declaration and definition. What is the difference between declaration and definition? Whenever we say integer A, right, in this we call it as both declaration and definition. So what does it mean? The name of the variable is a, the data type is integer, and when you don't initialize the value of a, by default it is going to take the garbage value. Okay. The meaning of this int a is nothing but the declaration as well as definition. Means we are declaring the type of the variable, and also by default it is going to take the garbage value. If you say integer a equals to 10, in this case also we are declaring it as integer a, and we are defining the value of a as 10. So this is both declaration and definition, right? Now we are going for what actually they meant by storage class. Please remember that a storage class determines what it is going to determine. It determines the memory location of the variable. It defines, or you can say it determines the memory location. And second one, default value. And third one, we are talking about scope of the variable, scope. And the last one we are talking about is lifetime. Memory location is also known as storage. Anything which determines or which defines where the variable is going to store, right? What could be the scope of the variable, and what would be the lifetime of the variable, and what a variable is going to take its own default value. When you don't assign a value to a variable, so what is the default value it is going to take? So all these four things are determined by a class known as storage class, right? Now, if you say integer a, okay, we call it as a variable. Before int, we use the storage class, any storage class. Here before int a, I'm using auto. See, what is auto? So what I want to say is storage classes are divided into four types, four storage class. The first storage class is automatic, and second one is register, and third one is static, and fourth one is extern. For automatic, you have to use the keyword auto, small letters AUTO. So for register, you use small letters register. For the static keyword, use the keyword static, and for extern, you use the keyword extern. These are the four storage classes, right? What I said, a storage class determines the storage, and also what is the default value, and what is the visibility. Visibility means scope, and what is the lifetime, at how much time it is going to alive. So that is called the lifetime. We will see each and every storage class in details in the coming classes. With this brief introduction, I want to close the session. Thank you very much for watching.